Okay, angular and linear speed. If you look at this formula, it looks crazy, right? They both look insane. We have omegas and thetas and radius and all sorts of stuff. So I find it easier to not worry about these formulas at all and instead cancel the units to get where we need. Before we can do that, we've got to talk about a few things. First, if you think about a circle, every rotation, revolution, one time all the way around the circle would be 2 pi radians, right? So that means we can set up a ratio that is either 2 pi radians in one revolution or one revolution in 2 pi radians, right? Oops, I went a little far there, sorry. So we can use those two ratios interchangeably depending on what needs to cancel. Also notice that we're using rotation and revolution interchangeably. It's the same thing. Okay, so the distance traveled in one rotation. So the angle traveled in one rotation is 2 pi radians, right? The distance traveled is the circumference, which is 2 pi r. So that means our ratio would be 2 pi r, whatever the units were in one rotation, or one rotation has 2 pi r units. So sometimes we have to, our problem doesn't give us the units and we've got to introduce them, and this is how we do it. So those two, both of those sets of ratios there are things that you might have to introduce yourself, that they're not already there in the problem. Okay, so we have a Ferris wheel at a carnival. There's the radius, and it has a rate of 1 revolution per minute. What I want you to do is, looking at part A, I want you to ignore angular speed, because radians per minute is obviously angular, right? Because it has radians in it. So what we're going to do is we're going to start with the information they gave us is 1 revolution per minute, okay? Notice we already have the minutes, so we're good. Now we need to get the radians, okay? And so to get the radians, we're going to have to introduce one of those ratios that we just talked about, and 1 revolution has 2 pi radians, okay? So now my revolutions cancel, and I'm left with 2 pi radians per minute. Okay, and that's the answer there. I guess they want us to work it out a little bit more, but whatever. You can pipe that in your calculator. On the second part, linear speed. Again, I want you to ignore that and pay attention to miles per hour, because miles is a linear amount, right? So again, we're going to start with our original 1 revolution per minute. And then I usually like to go ahead and take care of the time. So we have 60 minutes in an hour, which means that our minutes will cancel. And now we have hours. Okay, next we need to get miles. How do we get the miles? So we need to introduce a unit of measure, right? Because we just have revolutions per hour. So to do that, we'll use the circumference, and we will say that 1 revolution has 2 pi times 23 feet, right? Because the 23 is the radius. So now I have feet, but I need miles, right? So we're going to add that in. Oh, sorry, my revolution's canceled. And 1 mile has 5280 feet. If you don't know that, you might write it down somewhere, because we'll use that quite a bit with angular and linear speed. So my feet cancel, and I've got my miles. So I'm just putting everything together that needs to multiply, and I end up with 2 miles per hour. Okay, which makes sense. It's a Ferris wheel. If it goes much faster than that, people are flying off, right? All right, let's look at the next one. We have a bicyclist. Notice here they give us the diameter. So the circumference is just going to be pi d, right? And he is riding at 29 miles per hour. So first, they want radians per minute. So I'm going to start with what they give me, 29 miles in 1 hour. And then I'm going to go ahead and take care of the time. So 1 hour has 60 minutes. So now I can cancel those hours and I have the minutes, right? So next, I need to get the radians. So I'm adding in that I have 2 pi radians in 1 rotation, right? So, because I didn't have radians anywhere, so I have to introduce them. So now I've got the radians, but I need these other guys to cancel out, right? I need the miles and the rotations gone. So to do that, I'm going to use the circumference. 1 rotation has 24 pi inches. I'm getting the inches from the diameter up there. And then I've got to get from inches to miles. So, cancel out the rotations. Then I've got to get from inches to miles. So 12 inches in 1 foot, 5280 feet in 1 mile. My inches cancel, my feet cancel, my miles cancel. Now I'm good. So I'm just putting everything together. My pi's cancel there, that's nice. And I have 2552 radians per minute. Next, they want me to do, it says the number of revolutions in a minute. So we're looking for revolutions over minutes. So I start with my 29 miles in 1 hour. And I'm going to go ahead and take care of the time since that's pretty easy. My hours cancel and I have my minutes. So now I've got to introduce revolutions because there's no revolutions. But we know that there is 1 revolution has the circumference, right? Which is 24 pi inches. So now I have revolutions, but I need those miles and inches to cancel. So to do that, I need the conversion, 12 inches in 1 foot, 5280 feet in 1 mile. So now my inches cancel, my feet cancel, and my miles cancel. So I'm left with revolutions per minute. Just putting everything together, and I get 406 revolutions per minute. Okay. We have a ceiling fan. There's the radius and the revolutions per minute. They want to know first radians per minute. So we start with our original 44 revolutions per minute. And they wanted minutes. We've already got it, so that's great. We need to introduce radians, right? And there are, in 1 revolution, there are 2 pi radians. And so my revolutions cancel. I've got radians, so we're good. That's 88 pi, which is 276 radians per minute. Notice it says to round to the nearest whole number at the end there. Next, I want miles per hour. So we're going to start with revolutions per minute. As usual, I'm going to go ahead and handle the time, 60 minutes in an hour. So my minutes will cancel and I have hours. Now I have to get to miles. So if we've got to get to miles, we've got to introduce the circumference, right? So 2 pi times the 18, right, which is the radius, inches in 1 revolution, right? The circumference in 1 revolution. Now my revolutions cancel, but I have inches and I need miles. So we're going to put that conversion in, right? 1 foot is 12 inches, 1 mile is 5280 feet. Now my inches cancel, my feet cancel, and I'm left with miles per hour. So I can put everything together, 5 miles an hour. Okay. So again, all we're doing is putting everything together and canceling the units and really thinking about the 1 revolution has 2 pi radians or 1 revolution has the circumference. Last one, we're talking about Mars. It does 1 rotation every 24.7 hours. And here they're giving us the diameter. So for circumference, we'll use pi d. Okay. So we want radians per day. So we start with what they give me, 1 rotation every 24.7 hours. And we've just got to get rid, let's see, if we do the time, we'll do 24 hours in one day. So then my hours cancel and I have my day. But I don't have radians anywhere, so I've got to introduce the radians. So that is 2 pi radians in one rotation. So now my rotations cancel and I have radians. So we're just putting it all together and I get 6.1. If they wanted whole numbers, it would be 6 radians per day. Next, they want miles per day. So again, I start with the one rotation. And I'm going to go ahead and do the same thing I did before and fix the day. So my hours cancel, and now I'm left with the day. But now I need to introduce miles. So to introduce miles, now I need the circumference in one rotation, right? And they gave us the diameter, so the circumference is 4214 pi miles in one rotation. And so now my rotations cancel, and I have my miles. Putting everything together, 12,857 miles per day. Okay? So just really concentrate on canceling those units. You can do it.